All right, what we're going to do here is we're going to explain how to set up the formulas to find the volume of solid when it's revolving around a certain axis of rotation. In this one, we're going to specifically use the shell method. The shell method. Yes, the shell method. All right. Now, if you're in AB calculus, you might be extra credit on the EPR in your test. However, this is mainly for BC calculus. And so without further ado, let's talk about this. So what we're going to do is revolving this area region around the x-axis, okay, around the x-axis. Now, normally we'd always start with saying, okay, let's use possibly big R and little r, the washer method right here. However, the problem when we do this, okay, is that what you notice is that this region right here, right there, okay, we start to see that it overlaps each other. And that's a no-no. That makes us sad. Oops, sorry, sad. Okay, so because you see an overlapping region, some parts actually work out pretty well. But because we have that overlapping region, we have to use some sort of other method. Now, what we're going to do is we're going to use a shell method. Now, the shell method is where we take a shell that is parallel, all right, to the axis of rotation. So we're going to create this shell right here, okay? And this is going to be the length of our shell. And so when we figure out the shell method, we're going to take this, and we're going, and I always like kind of drawing it out, and we're going to take this length, which is well, kind of like height of our shell. I would say height, and that's going to be from here y squared over 2 minus the quantity y to the 4th over 4 minus y squared over 2. Okay, so that's going to be that length right there. Now we're going to take this, we're going to rotate it around and kind of run out of things. So we're rotating this around here, and we're going to create this little shell area. Now, from here, when we do that, you recall, if you watched the other video, is that we have then a radius. Our radius is from this length from here all the way to our axis of rotation. This is our radius. Now, our radius in this case is going to be our y value because we're going vertically like this. And so we have 2 pi, because since we're rotating around, we're finding this value right there. So if we lay it flat, okay, we're going to cut that out, and we would have, okay, our circumference of our circle. We'll have the y, we'll have our height right here. So if we add those two together, we'll have 2y squared over 2. All right, yeah, 2y squared over 2, which would be just y squared minus y to the 4th over 4. Okay, and that's going to be height. And then we have dy. We're going to be integrating this from 0 to this top part 2. And that was how we get our answer when we rotate around the x-axis. All right, pretty awesome, huh? Now, the thing is that we're going to do the same thing, but now if we change this up, like for example, if we start rotating this around some different axes, okay, a couple things change. The main thing that changes is not the length of our shell, okay, but what changes really is the, all right, radius of our shell. Because right here, if we start here, and let's say we go up to 5, I'll just say y equals 5 right there, another horizontal axis, but now we're rotating the shell around this way, okay, so everything will be rotated this way. So when we have that shell, okay, we can see that, okay, what is the radius? Well, the radius is this length from here to there, okay? And so what we have then is any x value, so this is in part, actually this is C, all right, I'm doing C, not going in order. All right, this is C. So what we have then is 2 pi. Our radius is no longer y because this length from here to here is any y value from 0 to 2, so it's going to be still 0 to 2, but we're going to take 5 minus whatever the y value is. That's what's going to give us our radius. Okay. Our length of our shell is the same, so that's our f of x. Okay, so that's just going to be the same thing. So that's going to be, if I simplify, I'm just going to go y squared minus y to the 4th over 4. Okay, and then we still have dy right there. So we see that the only thing that really changes is the radius of our shell in order to figure this out. All right, let's try another one. All right, maybe you can try some on your own. All right, if you're going to try B, you can pause this and see if you can figure it out. Okay, so once again, we're going to take with B. We're going to be rotating this around y equaling 2. Okay, so what is the thing that changes? Hopefully you notice that, yeah, the same thing is our axis of rotation, and actually our radius changes. So here's our radius. All right, so when we have this, we have 2 pi. We're still going from 0 to 2. All right, but now our radius is going to be 2 minus whatever y we plug in. Still, this distance from here to here is going to be y squared over 2 minus that quantity right there. Okay, and so what we have then is going to be y squared minus y to the 4th over 4 dy, and that's going to be our, all right, our thing. You can put in your calculator and you can figure this out, or you can do it by hand, but just to save time, I'm just going to do that. So let's one more. If we have d, okay, once again, what changes? Well, once again, our shell length doesn't change, but where we're rotating it does change. All right, where we're rotating it does change. And so if we have that, I'm going to do this one green. Okay, and so when we go d, we have this -1, so it would be -5/8. So we can see this, and now it's rotating around here. Okay. Well, here is our radius. So the radius of our shell. So we're going to have to integrate. Once again, going from 0 to 2. We have 2 pi, because we're still going to create a circumference of a circle. Our radius is going to be y minus -5/8. So it'll be plus 5/8. Just at the top, going to the bottom. Our length of our shell is the same as all the other lengths of the shell. So we say y squared minus y to the 4th over 4. And then dy is going to be our answer. And there we go. That's how we do it. That's how we do the shell method. Not too hard. It's actually kind of fun. And when you have a vertical axis and you rotating around, you just put everything in terms of x in that case. All right. Well, I hope this helps you out. Good luck and God bless in the rest of your problems.